Yes, guys, welcome back. Top Notch TV, ready now to demystify some elements of our biology. Today, let us engage ourselves in using some little bit of bones in order for us to demystify one or two areas. In our last session, we introduced the mammalian skeleton, and we did mention that our mammalian skeleton comprises of the exoskeleton, that is the skull and the vertebral column and the rib cage and the sternum, and also the appendicular skeleton, which we'll see later. Today, let's talk about what makes up the exoskeleton. Our exoskeleton can be divided into the following sections. We have the section that is the neck region, which we'll call the cervical region, and therefore the bones that form the cervical region, that is your neck area, are the cervical vertebrae. Cervical vertebrae. Followed by that, towards the posterior end, we have the bones that form the thoracic area. In the ventral position, we'll talk of the chest, but to the dorsal side, we'll talk of the thoracic vertebra. So the bones that form the thoracic region are the thoracic vertebra. Then we have the bones that form your stomach area, the abdomen, the abdominal region. Those are the lumbar vertebrae. Then we have the last portion, which we call the sacral and the caudal. However, today I want us to focus mainly on the cervical vertebra. The cervical vertebrae are normally 7. We have the first bone in your neck, or at your neck area, that articulates with your skull, and that is the atlas. The first bone will be the atlas. The second bone will be the axis. Then the remaining will be typical cervical vertebrae. Which are the unique features of these bones? Let's pick one. With me is the atlas. I also have with me the axis. I also have with me a representation of the other bones in the neck region, the typical cervical vertebra, this one. I also have with me a sample of our lumbar vertebrae, the lumbar vertebra here. There are some structures that are common in all these vertebrae. However, our focus today is to identify what are the unique features of each of these type of vertebrae. Let us start with the atlas. So we focus on the cervical vertebrae in this session. Let us start with the atlas. If we look at the atlas, one, there is a very wide opening. This opening, that is where the neurospine passage of the neurospine. And you see, being the first bones following the head, where the brain extends posteriorly to form the spinal cord, this through opening, it is wide to allow passage of the spinal cord, and this is what we call the neural canal. Therefore, the first key and unique feature of the atlas is a wide and wide neurocanal for passage of the spinal cord. I want us to focus on the anterior end or on the anterior view of this atlas. And we said in our previous session that anterior means facing the head. How will you know which is the anterior side of this bone? If we study this bone, on this face, we have some depressions. We have some depressions here. But on the other side, the end is kind of flattened and smooth. So on one side, you have depressions. On the other side, opposite side, you have some smooth surfaces. Now, these depressions are the ones that allow you to nod your head. They act like pivots to allow you to permit the nodding movement of the head. That tells you that this is the anterior side of the atlas, and we call this anterior depressions. They are anterior depressions. Their function is to enable articulation with the lower part of your skull. And the lower part of your skull is what we call the occipital condyles. The occipital condyles. Anterior depressions for articulation with the occipital condyles. Why is it that the other side then, which now we can conveniently call the posterior side, has some smooth surfaces? These smooth surfaces are to enable this atlas articulate with the bone coming after it, the bone on this posterior, on its posterior side, and this bone will be the axis. We'll mention it. But then we can pick this as a unique or as a distinguishing feature of the atlas also, that is smooth surfaces on the posterior for articulation with the axis. The axis will be on the posterior of the atlas. Let us focus on the side that is the lateral view of this atlas. In the lateral view of this atlas, we have some widened surfaces or structures that appear like forming wings. And these wing-like structures are for attachment of your neck muscles. Attachment of your neck muscles. These, we call them, they are the ones called the transverse processes. The transverse processes on either side, the transverse processes. And therefore, the atlas has wide and wing-like. Actually, the key thing unique there is wing-like transverse processes for attachment of the neck muscles. For attachment of the neck muscles. Finally, in this bone, we have some openings. We have some openings that get right into the neurocanal. We have some openings that get direct into the neurocanal. We call that vertebratorial canal, the vertebratorial canal. The atlas has vertebratorial canals, and that is for passage of the vertebral artery. Vertebral artery, passage over the vertebral artery into the neurocanal, of course, to take nourishment to the neurospine. So the unique features of this atlas as a bone are Anterior depressions, the anterior depressions, that is to allow articulation with the occipital condyles of the skull. Wing-like transverse processes for articulation of the neck muscles, and wing-like, obviously, or by extension, provides a large surface area for attachment of the muscles. And then smooth posterior surfaces for the articulation with the axis. Besides those unique features, we also have the vertebratorial canal for passage of the vertebral artery as a characteristic feature of the atlas. After the atlas, the next bone in the cervical region is the axis. Now, the axis has one key unique feature. And this unique feature is this elongation here, this protrusion. This protrusion is the portion that fits into the axis. That protrusion is the one that we call the odontoid process, And because the odontoid process is for articulation with the atlas, then that identifies or tells you that this is the anterior view or the anterior side of this body, because it is the one that faces the head. It's the one that will articulate with the axis which is above it, which is towards the head. Besides that, notice that there is an elongation here. This elongation is the neurospine. The neurospine was not so protruding in the atlas, but in the axis, we have broad neurospine, and that neurospine is for attachment of muscles. Broad neurospine for attachment of the muscles. Let us focus or introduce something new also, which was not visible in our atlas. So this is the odontoid process, and this odontoid process is on the anterior of the axis. What about the posterior of this axis? If we look at the posterior of this axis, it appears like being pushed in. It appears like forming a depression. It is like being pushed to push the odontoid process to elongate outside. That depression tells you that that is the posterior side. That is the posterior side. This is the axis. Two unique features. One, the presence of the odontoid process for articulation with the atlas. Two, broad neurospine for attachment, to provide a large surface area for attachment of neck muscles. Let us mention something about the remaining cervical vertebrae, which I have a sample here. This is a sample cervical vertebra, and it appears to be so much branched. And already there are some features that we can relate to, like wide neural canal for passage of the neurospine. We will have the vertebratorial canal for passage of the vertebral artery. Now, if we take this cervical vertebra and we look at the centrum, that is where the transverse processes emanate from. The centrum, that is where you will have the other bones joining or articulating. That is where we'll have adjacent bones articulating with each other. This centrum, on one side, it forms a depression. On the opposite side, it forms a protrusion coming out. If we use an example or the axis as our benchmark, the part of the centrum that forms a protrusion forming the odontoid process indicates the anterior view. The part of the side of the centrum that forms a depression indicates the posterior view. Therefore, if I take this cervical vertebra, this side that where the centrum forms the depression, it tells me this is the posterior view because of the depression. This side where the centrum forms a protrusion, it tells me this is the anterior view. So, amongst this cervical vertebra, we can clearly identify the anterior view and the posterior view. Now, one key unique feature about the other remaining cervical vertebrae here is branched transverse processes. They are branched transverse processes, branched to increase the surface area for attachment of neck muscles. Also, there is a neurospine for attachment of the neck muscles, but it is not so uniquely modified to be a distinguishing feature. Now, let us use this cervical vertebra also to distinguish two confusing structures. These structures that we call zygapophyses. Zygapophyses are smooth surfaces for articulation with adjacent vertebra. Smooth surfaces. Now, if I take one of these cervical vertebra and I have the other cervical vertebra, remember we have said where the centrum forms a depression, it shows that is the posterior side. Where the centrum forms a protrusion coming out, that is the anterior side. So this is the anterior, this is the posterior. In this cervical, this is the anterior because this is where the centrum forms a protrusion. This is the posterior because this is where the centrum forms a depression. So if I have these two cervical vertebrae, this is how they can fit into each other. The anterior of this cervical vertebra has to fit or should fit into the posterior of the other. As they do that, we have these two pairs of smooth surfaces. This one and these ones. These are the zygapophyses. Now, these zygapophyses that are on the posterior, what has told us that this is the posterior is the depression on the centrum. These zygapophyses are characterized by two things. One, they appear facing down. They appear facing down like this. At the same time, they appear facing, shying away from each other. So they are facing down, yes, but they shy, quote unquote, away from each other, facing down, but again trying to be moving outwards. This zygapophysis that faces downwards and outwards, they are on the posterior side of that vertebra, and therefore they are the post zygapophysis because they are on the posterior, post zygapophysis. They face downwards and outwards. On the other side, we have the same similar zygapophysis, but in this case, this zygapophysis, they are facing upwards, but then they tend to like each other. They are trying to say hi to each other. They're facing inwards. They're facing outwards, but tilting inwards. And because they are on the anterior, side, it means they are for articulation with the bone that is before this. They are for articulation with the bone that will be before this cervical vertebra, and therefore they are the pre-zygapophysis. Pre-zygapophysis, they face upwards, and pre-zygapophysis, they face upwards and inwards. Post-zygapophysis, they face downwards and outwards. That distinguishes the two categories of zygapophysis. With that, it then enables us to say that the cervical vertebra has clearly defined both pre-zygapophysis and post-zygapophysis. Remember, one unique feature of this cervical vertebra is branched or forked transverse processes. I hope that demystifies some of the unique, using these unique features, it demystifies or it removes the usual confusion that we experience in distinguishing one, the features or identification of the atlas, the axis, the cervical vertebrae, the unique features, and then how to identify, especially the anterior view and the posterior view from each of them. Remember to subscribe to our favorite online TV learning platform, the Ocean of Knowledge, TOPNOTCH TV, and also you can easily obtain very comprehensive charts describing these unique features and others from our TOPNOTCH offices and the contacts below the charts. Until our next session, bye-bye.